Hello, I'm Kiran Kumar from Nature of Physics. Today topic is motion of a vehicle at the turning of road. So the necessary centripetal force is provided to the vehicle by the friction and normal reaction component students. See here total 3 are there. First one is by friction only, second one by banking of road only, third one by friction and banking of road only. So student, please do like and subscribe our channel Nature of Physics. Step by step clearly I am going to explain, including one numerical also student related to this topic. See there. So vehicle turning needed necessary centripetal force. It is provided by the three methods on the vehicle student. So by friction, by banking of road, by both the friction and banking of road. See there, first one by friction I am going to discuss student. This is the circular road, okay, and O is the center of this circle, and this is the banking of road. For example, assume like this is a car student, okay, and normal reaction is acting, that is vertically upward, vertically up, and downward direction is mg acting, so vertically down. There is a weight of the vehicle acting student, and also here at the turning area on the car toward the center there is a centripetal force. The necessary centripetal force is provided by the frictional force student. Whenever here centripetal force is there, centrifugal force are there, both are equal in magnitude and opposite direction. Centripetal force is the force which is acting toward the center of the circle. Centrifugal force is the force which is acting away from the center of the circle on the vehicle student. So that balancing conditions I am going to write here student. So here n is equal to mg, both are equal in magnitude and opposite in direction, no need to discuss about it. And there is a centripetal force Fc which is less than or equal to frictional force student. Okay, so the centripetal force formula is mv square by r is the radius of this circular road student, less than or equal to friction we can write as mu into n. Okay, so that mv square divided by r less than or equal, here the frictional force I am considering as limiting friction student, limiting friction, so that mu l into n value is replacing, that is mg, and mm get cancel, so that I got v square less than or equal to mu l g into r, so that v which is equal to less than or equal to root over mu l into gr. So maximum velocity I am writing v max which is equal to root over mu l into gr. This I can write as equation number 1. So this is the maximum velocity to take safe turn on the circular road. There is no banking of friction student, only circular road. Frictional force and centripetal force is balancing here, clearly given equation 1. And next I am going to explain second one is by banking of road only. See there student, O is the center of this circle here, okay, and next one, this is the circular road, r is the radius of the circle student, r is taken as radius of this circle, and banking theta is the angle of banking student, okay, and this is for example taken a car student. On the car normal reaction is perpendicular to the surface, see there, exactly perpendicular to the surface, okay, and next one, normal reaction is resolved into two component. This is n cos theta towards theta, and n sin theta is mutually perpendicular, okay, and also weight of the body is acting downward direction mg considering. On the car always centripetal force and centrifugal force is acting. Centrifugal force is mv square by r, and here balancing conditions I am going to write theta is the angle of banking, theta is angle of banking. See there. Now here balancing equations I am going to write. First one is n sin theta, n sin theta which is equal to mv square divided by r. This is I can write as equation number 1. And next one is n cos theta which is balanced by mg. So this is I can write as equation number 2. And continuation, next step, equation 1 divided by equation 2. See there, n sin theta divided by n cos theta which is equal to mv square by r divided by mg. In this equation, is get cancelled and also n also get cancelled. So sin theta by cos theta is tan theta which is equal to m already completed. Okay, slowly I wrote mv square divided by r into mg, writing student. Okay, so tan theta which is equal to v square divided by r into g. Okay, and this is I can write as equation number 3. Okay, and continuation step here, v square which is equal to gr into tan theta and v which is equal to root over gr into tan theta. This I can write as equation number 4. This is clear information about the banking of road. Once again see the diagram. There is a car of mass is m, downward direction mg acting perpendicular to the surface is normal reaction. So normal reaction is resolved into two components, that is n cos theta and n sin theta, mutually perpendicular, clearly represented. So there is a centrifugal force and centripetal force, both are equal in magnitude, opposite in direction. Okay, so that balancing equation already I written equation 1 and 2. So equation 1 by 2 I got the tan theta is equal v square by rg, so that v is equal root over gr tan theta. Wait a continuation, third point is by both friction and banking of road. See, the necessary centripetal force here provided by the component of frictional force and also normal reaction. Okay, to avoid slide down, the minimum speed is required for the vehicle. The vehicle is taken as bus on the banking of road. Theta is the angle of banking of road, O is the center of the circular road, and here on the road m is the mass of the bus, downward direction is mg acting, and also normal reaction is perpendicular to the surface, that is perpendicular to the inclined plane, and normal reaction is making an angle theta with the vertical. So that normal reaction resolve into two components, that is n cos theta and n sin theta. So that there is a frictional force is acting. So here the case is slide down, so that frictional force is acting away from the center, student. So that frictional force also resolve into two components, so that it is making an angle theta with the horizontal. So that f cos theta is the horizontal component, f sin theta is the vertical component. Now balancing equation I am going to write, but on the circular road, on the vehicle, two forces are acting. One is the centripetal force acting toward the center, another force is the centrifugal force acting away from the center. So that here according to the diagram we can notice n sin theta is greater than to the centripetal force or centrifugal force, student. The reason is what? Here n sin theta is balanced by the mv square by r plus f cos theta. So that I am going to write, so that n sin theta is greater than to the mv square by r. So balancing equation along the horizontal axis, that is n sin theta which is equal to f cos theta plus mv square divided by r. See there, we need velocity, so that n sin theta minus f cos theta which is equal to mv square by r. See there, and continuation, this is taken as equation number vertical direction balancing equation I am going to write, student, there. So that n cos theta plus f sin theta which is equal to mg. This I can write as equation number 2. Okay, now equation 1 divided by equation 2, see there, equation 1 divided by equation 2. So for this, n sin theta minus f cos theta divided by LHS side n cos theta plus f sin theta, which is equal to mv square by r divided by mg, student. Okay, so next step is here m and m is get cancel. Okay, and here f is equal to mu into n, value is replacing in the above equation, so that the frictional force is taking as here kinetic friction, so that n sin theta minus mu k n cos theta whole divided by n cos theta plus mu k sin theta, which is equal to v square divided by rg. So that n numerator and denominator common and cancel, student, here, and continuation there, sin theta minus mu k cos theta divided by cos theta plus mu k sin theta, numerator and denominator normal reaction common and cancel, so v square divided by rg. So the velocity equation v, which is equal to root over gr into sin theta minus mu k cos theta divided by cos theta plus mu k sin theta, student. So the minimum velocity equation v minimum, which is equal to, this is I can write as equation number 3. First equation I got, and next second equation just modified equation, see there, see rg into numerator and denominator dividing by cos theta, student. See there, v minimum, which is equal to root over r into g sin theta by cos theta tan theta minus mu k cos theta is get cancel divided by cos theta get cancel 1 plus mu into tan theta. This I can write as equation number 4. These two represent the minimum velocity equations. Okay, see, simple logic, student, try to understand, just balancing the equation. Here I am resolving normal reaction is resolved into two components and frictional force also resolved into two components, but mg and centrifugal force is remains constant. Based on the balancing equations, horizontal we are getting and also vertical we are getting skid up. A vehicle is turning on a circular road with banking of road and friction both are there, so that to avoid this skid up, maximum speed is required. Skid up nothing but downward direction frictional force is acting. Previous slide down, that's why frictional force is upward direction. Now skid up, that's why frictional force is acting downward direction, so that frictional force is resolved into two component. Horizontal component is f cos theta and vertical component is f sin theta is acting downward direction. And also always weight of the vehicle, this is feel like a lorry, and downward direction mg is acting, and perpendicular to the normal reaction, perpendicular to the surface is a normal reaction. Normal reaction also resolve into two component, already we did in the previous cases. N cos theta and n sin theta mutually perpendicular each other. There is a centripetal force and centrifugal force, both are equal in magnitude and opposite in direction. So we are considering for balancing purpose centrifugal force. Okay, and balancing equation I am going to write, student. See there, n sin theta plus n sin theta plus f cos theta which is equal to mv square divided by r. See there, n sin theta and f cos theta which is equal to mv square by r. See there student, horizontal direction balancing equation completed. This I can write as equation number 1. Next, vertical direction n cos theta is there. So n cos theta is equal, downward direction is f sin theta plus mg. Rearranging this equation, n cos theta minus f sin theta which is equal to mg is written as equation number 2. Okay, now using equation 1 and 2 we will get the maximum velocity to avoid the skid student. So that equation 1 divided by equation 2, for this n sin theta plus f cos theta whole divided by n cos theta minus f sin theta which is equal to mv square by r. Numerator denominator is mg, m and get cancel, so that we are getting their frictional force also replacing. F is equal to mu k into n, so that n sin theta plus mu k n cos theta divided by n cos theta minus fk value replacing, that is mu k n into sin theta which is equal to v square divided by rg. Okay, so that numerator and denominator normal reaction common and cancel, so that sin theta plus mu k cos theta divided by cos theta minus mu k sin theta which is equal to v square divided by rg. And next step I am going to write v square value, v square which is equal to rg into sin theta plus mu k cos theta divided by cos theta minus mu k sin theta, so that v which is equal to whole root r into g sin theta plus mu k cos theta divided by cos theta minus mu k sin theta. See there, so that I can write this is equation maximum velocity, so that is I am considering as equation number 3. And also sin theta by cos theta is tan theta, that's why 1 by cos theta which is equal to root over gr sin theta by cos theta plus mu k cos theta by cos theta divided by denominator cos theta by cos theta minus mu k sin theta divided by cos theta. Cos theta cancel, so that the velocity equation Vmax which is equal to root over gr into tan theta plus mu k divided by 1 minus mu k tan theta. See there, I can write this is equation number 4. Clear information for maximum speed to avoid the skid up on the circular road. Okay student, so one thing we have to notice, that is numerator here tan theta plus is there, that's why velocity is maximum. Here 1 minus is there, denominator is minimum, that's why LHS side here velocity is maximum. And previous one, See student, here also velocity is minimum because of numerator tan theta minus is there and denominator 1 plus mu tan theta is there. See, numerator is minimum, that's why velocity is minimum, because of velocity is directly proportional to tan theta minus mu k and inversely proportional to the 1 plus mu k tan theta student. This is clear information about the both friction and banking of road. And one more numerical is there. Wait a second. A cyclist is moving on a unbanked road with a speed 7 km per hour. That is horizontal road with a speed is 7 km per hour. A time taken to sharp circular turn along a path of radius r is equal 2 meters without reducing a speed. The static friction coefficient of friction is 0.2. The cyclist will not slip and pass the curved path, that is circular path student. And continuation, next one statement 2 is there. If the road is banked at an angle 45 degrees, cyclist can cross the curve with the radius 2 meter. The speed is 18.5 km per hour without slipping. In the light of above the statement, choose the correct answer from the option given below. Okay, so 4 options are given student, we have to select the correct option. So first statement is, that is circular road only, there is no banking of road, V is equal root over mu g r. Okay, and replacing the values whatever given in that. So V, which is equal root over mu value is 0.2 given, G value is 10 and R value is 2 meter. That value is root over 2 square root of get cancel. Finally I am getting V is equal to meter per second. See, here the speed is given according to the question. This I can write as the maximum speed student. What is that? Maximum speed. So I got the maximum speed, that is equal to 2 meter per second. But according to the question, the cyclist is moving with a speed 7 km per hour. 1 km per hour is equal 5 by 18 meter per second. So that after solving we will get 1.94 meter per second. So that the person is safe cycling on the circular road because of the speed of the person is 1.94 meter per second, but the maximum speed is 2 meter per second. So that 1.94 is less than to the 2 meter per second student. And next one, statement 2 is theta is equal 45 degrees given. So mu is equal 0.2 given, r is equal radius 2 meters and g is equal 10 meter per second square. So that according to the question, on the banking of road, same cyclist moving with a speed 18.5 km per hour, that is again converted into meter per second. So I am getting 5.13 meter per second. So that we have to find the minimum speed and also maximum speed student. Wait a second. So first I am going to write about the maximum speed. What is the maximum speed formula we got student? So the maximum speed Vmax, which is equal to root over gr into tan theta plus mu k divided by 1 minus mu k into tan theta. Okay student, and the values are replacing now. See that Vmax, which is equal to root over G value 10, R value is 2 and tan theta, that is tan 45 plus mu k value is given 0.2 divided by 1 minus 0.2 into tan 45 degrees. See student, tan 45, which is equal to 1 and values are replacing. Vmax already replaced, that is 20 into tan 45 1, 0.2 divided by 1 minus 0.2. After solving this, we will get V max, which is equal to 5.47 meter per second. And next one we are going to find about the V minimum, student. See there, V minimum, root over GR into tan theta minus mu k divided by here 1 plus tan theta. So V minimum, which is equal to root over G value 10, R value 2, next tan 45 minus 0.2 coefficient of friction divided by 1 plus 0.2 into tan 45. Already I gave you tan 45 is equal 1. After solving this, we will get V minimum, which is equal to 3.65 meter per second. So one thing you have to notice there, the given value of the cyclist is, that is V is equal 5.13 meter per second. See there, but V minimum is 3.65. yes, minimum only, less than to the 5.31, and V maximum is greater than to the V, student, that is 5.47 is greater than to the 5.13. in that both statements, statement 1 is correct, even statement 2 also correct, student. Please do like and subscribe our channel Nature of Physics.